I hope you can hear me and see my screen now. Excellent. So yeah, my full name is, as Paulo said, Evangelos, but people call me typically Evan. I'm an assistant professor at TU Delft, Faculty of Industrial Design Engineering, but I'm a computer scientist, so I'm not a designer myself. I'm a computer scientist in the area of HCI. For those who don't know the acronym, it stands for Human-Computer Interaction, and it's studying the effects that technology have on human cognition and perception. So in that respect, the project fits very well within my research interests. And without further ado, I'll just give you an overview of the project for those who haven't seen it before. In a nutshell, we have the following situation at the moment in the context of the EU factory in the European Union, but also outside the European Union. We have some specific facets we're facing when working with the manufacturing domain, and that is the specific, like long distances. Like people who work in this domain experience long distances and narrow spaces, typically because the whole space is filled in with machinery. Of course, on top of that, you have increased noise levels that basically require sometimes to well-protected equipment. And at the same time, we're experiencing what we call declining workforce. So we observe an increasing amount of people going to retirement or moving to other domains of the sector, and even fewer people, newer people coming into it. So the workforce is actually declining. And that has led the sector to adapt increasing automation, so automating tasks with more smarter machines and introducing far more sensors and IoT and Internet of Things and APIs, application programming interfaces, into this manufacturing domain. And that's again because driven by the need of automating the tasks because they don't have enough people, clearly. But what we observe also is that despite the increased tendency for automation, there's still a lot of manual labor taking place in this context of manufacturing. And in this particular project in COALA, we work with three different use cases. We have the textile, we have the chemicals, and we have the appliances. And of course, I will go into these details later on. But in this webinar, we will focus mostly on the production of chemicals by Diversi in the Netherlands. The real challenge that we face when we deal with factories today is that it's costly and time-consuming to train and onboard new operators. What we typically do in these factories is that you put like a new person next to an experienced person, so that there is some what we call transfer of knowledge between the experienced person or the wise person, the senior person, typically speaking, to the novice one. And the problem, again, as we mentioned before, of the declining workforce is that we have very few operators that call themselves experts and can be considered as experts. So on top of that, we have tacit knowledge. Tacit knowledge is the one that is hard to express and share. For example, if I ask you, how do you ride a bicycle? Like for those who know how to ride a bicycle, I guess it comes innately and it's hard to describe it, I guess. So that's part of tacit knowledge. So it's knowledge that manifests itself on the task, basically. And on top of that, we have also that knowledge that is hard to collect, not because it's only tacit, it's because it gets lost. And any knowledge you connect, you have to basically structure properly, belongs to the organization, and it could include machine instructions, quality reports, product specifications, and so on, and other actually details. And in order for these knowledge to be relevant in the new context of agile manufacturing, you also have continuous investment in this structure that maintains the knowledge. And at the same time, we experience what we call at the moment a paradigm shift between Industry 4.0 that most of you should have heard of to Industry 5.0. So what's the difference here? So we're moving from smart manufacturing with sensors and IoT to human-centric manufacturing, which is putting the human in the center and structuring the manufacturing around the human as an operator in the production line. And here comes COALA, basically to try to navigate in this complex context and complex landscape of today's manufacturing. And the main aim of COALA is to provide a solution that, with cognitive assistant that consists of composing trustworthy AI components that are voice enabled in order to provide intelligent assistant through an interface that can actually be either text based or voice enabled interface. And the solution is comprised of two main pillars, users analytics and on-the-job training. And in that context, we have several partners. So we have, as you can see here on my screen, the top box contains the research or academic partners, which is basically those who come up with the ideas on how to tackle the problem. We have solution providers, and we have innovation management partners. And finally, we have the end users, which is actually the factories, the actual organizations that open the doors for us and allow us to deploy our solutions according to those two pillars we have here. And specifically, we have textile production by Piacenza with specific aims in this case, which is reducing the time and cost of machine operator trainings, maintain the workers' autonomy versus unquestioned execution of instructions. We don't want people to blindly follow the instructions that the cognitive advisor provides them, but we want them to act as a reminder for what they know, and exploit and spread the concept and solution. That's the idea of what we're trying to achieve in the context of textile production with Piacenza. Then we have Whirlpool, and the main point there is to adapt the predictive quality strategy. So they mainly focus on analytical tools on the production of production analytics. We link the quality control of the finished product with the design stage and the shop floor. And the idea is to reconfigure the production line and facilitate root cause analysis. That's where it helps, mostly where the advisor helps the Whirlpool in this case. In the diverse case, which is going to be the use case of today's presentation and generally the webinar, the aim is to increase efficiency of production by reducing, also at the same time, reducing change over time, to capture the best practices and transfer them from typically the ones who come with best practices are the ones who are the senior ones or the people who work for longer time into the factory, and transfer that knowledge from the experienced ones to the novice ones, as we said. So it's mostly aligning with the second pillar of COALA, which is on the job training. And of course, tacit line knowledge capturing, formalization, and transfer that to workers. So as I mentioned before, the aim here is also to locate and find, like detect when there is tacit knowledge being generated. For example, the advisor is, by being connected to the APIs of the company, can detect when the production is going up, when the yield is better, when there's less faulty products, and basically nudge the operator currently on the production line to enter the knowledge of what they did right. For example, they can ask a question like, what did you do right in this point? And then they can enter the knowledge on the spot into the advisor, and that knowledge gets stored in the knowledge base and becomes available at a different time to a different person. That's the main point of on-the-job training and knowledge sharing here. Let me see if I have another one here. Yeah, so just focusing most on all our main features here, we have augmented manufacturing analytics, which is mostly focusing on the Whirlpool use case, as I mentioned before. The aim here is to provide novel prescriptive quality of analytics and service, to simplify the access to analytics through a conversational interface, and explain prescriptions to improve trustworthiness of the AI basically employed. But as I said before, the focus on this webinar will be on cognitive assistance for on-the-job training. Again, collecting the workers' experiences through a conversational interface, giving them advice based on more experienced workers' experience and knowledge. And that could cover students, novices, and experts, and adapt the behavior of advising with the learning progress. So, for example, you want to give the knowledge that is right for the specific person. You don't want to give more difficult or more complex knowledge when someone is not yet ready. So you follow up with their progress of learning progress by what we call giving them learning nuggets, as you can see here, for example, in the screenshot, so that they get different steps of increasing difficulty in their knowledge and filling the gaps of what they don't know. That's the idea here. So not to blast them with knowledge that they don't need to know. So with this, I think we are okay through the introduction, and I can pass the token to Nicholas, I think, and then I will be talking more later.